Topic number 1. Here we go. You should have your notes page in front of you, and we're going to work on topic number 1. It refers to vector and scalar quantities. And I want to state to you right now that I took a fairly major decision not to include Newton's laws as topic number 1. Please, for goodness sake, make sure you develop that knowledge, because it's very frequently assessed as individual questions and used as knowledge within other questions. So you need to develop it. I simply leant towards not including it based on rhythms of papers, but you must understand it. So I'm explaining to you today that in terms of quantities, numbers, we have two types of quantity. We are saying we have something called a vector quantity and something called a scalar quantity. So let me be clear. A vector quantity, let's say displacement as an idea. Just going to make a change to the horrible error which is on the page to velocity to speed and the scalar quantity. But a vector quantity has both magnitude, that is to say that it has a size, and it has a direction. Okay, so a vector quantity has to include this concept of direction, whereas our scalar quantities have a magnitude only. Magnitude only. Now, I don't know if the word magnitude means a lot to you. It means scale or size. So, for example, if we were to describe the distance of a swim, we could say that they swam one length, this swimmer. So they swam down the pool and they covered a distance of 50 meters. If they came back, they covered a distance of 100 meters, for example. But it doesn't describe the direction in which the athlete has traveled. It simply talks about a scale, a size. So therefore, it is a scalar quantity. Whereas if we talk about something like displacement, for example, we would say that the swimmer completes one length. And again, we would describe this as a displacement of 50 meters, but we would say specifically in that direction, or we could describe it as northwesterly, or we could describe it as southerly, depending on which direction it is in. By the way, with angular displacement and later with angular velocity, we would describe it as the turning of a circle. So we would refer to it as something, some number of radians or degrees, clockwise or anti-clockwise, more of which later on. So what we're saying though is, in terms of displacement, if the athlete swims back in the 100 meter freestyle, say, then their displacement is 0 meters. And you might be thinking, what? Well, the thing is, they've ended at the same point. Let me just change colour there. They've ended at the same point that they've started at. So when you take into account the magnitude of the position of movement of the performer in the direction that they move in, then of course that then suggests that they've ended in the same place they started, or more or less, and therefore their displacement is 0 meters. And we can say the same for something like an athletics track. If we have a 400 meter runner who, not around the crowd, but runs round here and wins their gold medal or whatever, then we can say that they have covered a distance of 400 meters, right? But they have displaced 0 meters because they've effectively ended back at the start point. Likewise, if we were looking at something like a 1500 meter run, and the 1500 meter start line is somewhere over here, is somewhere over there. Okay, so what they're going to do is the performer is going to complete their first lap here, which is a 3/4 lap, and then they're going to do 3 more. So in terms of distance, the performer has covered 1500 meters. But in terms of displacement, and this is a really interesting point actually, in terms of displacement, you might say, well, they've displaced 300 meters because they've gone round here. They've gone round here. They've displaced 300 meters. But in fact, it's not true. They've displaced, let me do that again. That wasn't very good. They have actually displaced whatever this distance is. Whatever that distance is there. That's the displacement which they've made, because we have to say that displacement is as the crow flies, a straight line between the start and the end point. Now, the only other point I want you to realise that velocity is vector while speed is scalar. Then we have numerous other vectors here. Force always have to be vectors. Anything which is a vector can be illustrated with an arrow, and we're going to come back to that ever so imminently. Weight, for example, is mass times gravity. So mass itself is scalar, but when we times it by gravity, which of course always takes place in the direction of the center of the Earth, then of course it becomes a vector. Momentum is also a vector. Mass times velocity is momentum. So the mass, of course, is scalar, but the velocity part is vector, so it becomes vector. And again, angular displacement and angular velocity are also vectors, whereas angular distance and angular speed, goodness me, James, can't believe I included that in there. Angular speed is a scalar, so we need to understand this concept. So let's see what we'd get in terms of a question here. So the question asks us this. A swimmer completes 3 lengths of a 50-meter pool. Now, I hope you can already realise that what we have just covered, therefore, is touching on this concept already before we even look at the answer itself. So it's saying here, define the terms distance and displacement. So we simply need to give a definition and give values for both once the swimmer has completed the 3 lengths. Okay, so let's first of all go through our definition. So it's asking us to do distance first. So in my answer, you're going to obviously do this online, papered with black writing, and you're not going to use arrows unlike me. We're going to say distance, and we know it's a scalar, is simply the length of the path taken. Length of path taken. Okay, so on that basis, we can also say that the distance that this performer has actually covered is 150 meters, right? And we can show that on our illustration back up here. If the performer gets in here, swims, 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 they have completed 3 times 50 meters, and that is 150 meters, right? It stands to reason. Whereas if we talk about displacement, we have to refer to the direction of travel. So let's see if we can give a sharp definition and then show our quantity. We're saying here it's the shortest straight line route. So make sure we can define in that way. Shortest straight line route. Okay, from the start to the end point, right? In fact, let me clarify that. Between 2 positions. Between 2 positions. So let's go back to our image and let's look at what the 2 positions are. And I'm sure you're saying, James, we already know this, but let's just confirm. We're saying that this is the start position. The swimmer goes up 50, comes back 50, and up here is the end position. So what is the shortest straight line route between the start and the end position? Well, of course, the answer is going to be 50 meters of displacement. 50 meters displaced. And we would need to say, if we were doing this in a more pure sense, we'd need to say in which direction that is. So let's call it northerly, for example, in that direction there. So I want you to develop an understanding of this, because I really think that it's something so simple, but can cost you. Look, it might not seem much here, but we've got 4 marks available. Now, I also want to just explain one other point I've made to you here. This 4-ness in the question has not been ignored by me. It's not just I've whacked the answer down. We've been asked to, here's skill 1 over here, to define distance and displacement. Now, we should know as good students that means that's worth 2 marks, 1 mark each, because that's going to be half of these 4 marks, and give values for both. So there's 1 more mark for each there. So when I read this question, I'm already interpreting that the examiner's going to come along, albeit electronically, and they're going to circle, tick, and 1 mark the definition, circle, tick, 1 mark the value. That's in there. And they're also going to circle, tick, 1 mark the definition for displacement, and circle, tick, 1 mark before adding max answer, 4 marks for that. So I'm interpreting the question type on that basis, okay? And I encourage you, and we'll look at other skills like this throughout the session, I encourage you to be able to do that. Now, I'm going to say one other point which I think is really essential. Sometimes what students do, I've found in the past, is they see, let's say, 4 marks, and they only ever put down 4 points. And I understand why someone would do that. I mean, I've just done that, right? Because there's really only 4 points to make. But if you're asked for, if it's a question of discuss this or describe, and it's worth 4, 5, or 6 marks, and you've got 8 answers, put them down. Okay, never leave the knowledge in your head, because you can't be 100% sure of exactly what's going to be on the mark scheme. Neither can I, by the way. Sometimes mark schemes are odd little things. You may have found this as you've been through the course, right? So never ever leave knowledge in your head. It just happens in this particular case. It's really discernible where those 4 marks are coming from. All right.